Welcome everyone to the Boltathon. This is the world's first online Lightning Network conference and hackathon. Um, so I'm super excited to introduce to you our first speaker. This is Alex Bosworth, and he is the Lightning Infrastructure Lead at Lightning Labs. And the topic that he's going to talk about today is called the major limitations of the Lightning Network. Now, personally, I'm a huge fan of Alex. I think he's an awesome guy, very humble, but a constant builder. And, he was actually one of my first guests on my podcast. So I'm very appreciative of him and everything that he does for the space.
Okay, great. Let me work on this. Hold on one second. Well, definitely thank you, Andrew and Patrick, for putting all this stuff together. It's been really awesome. I think this is kind of like a unique experience. It's cool to see people from Bosnia and Ukraine, Uruguay, all coming to be able to go to one of these conferences. So I think this format is super cool. And also, I like the idea that you can buy the tickets with Lightning, that we're kind of using Lightning to build Lightning. So thanks a bunch. Okay, so I had a Twitter poll to kind of decide what to talk about. And people seem pretty interested in the limitations, what's the line, where is the line of what Lightning can do and what Lightning can't do. So that's what I kind of want to talk about to make it more clear, what can be done and what can't be done. So when I first started really focusing on Lightning, I thought what is the goal of Lightning? What is the goal of the Lightning Network? And something that really clicked to me is what if every transaction in the entire world was a Lightning transaction? And I mean, of course, that it doesn't really make sense because there's so many different transactions in the world. But I like it as a point off in the distance, a goal that we could kind of shoot for, of saying that how can we make this network be able to support and be compelling for every transaction that there is ever. So the thing to really think about though with Lightning is the definition of Lightning is it's really based on these these channels, right? And the channels have balances that are kind of fixed, that I have somebody on my side and you have somebody on your side. And fundamentally, all that we're really doing when we're using Lightning Network is we're saying, I'm going to move some of my side over to your side, or you're going to move some of your side over to my side. And we use HTLCs to kind of multiply this effect so that we can say, well, you move some, I'll move some over to you, and you move some over to somebody else. But that's still the fundamental boundary of the Lightning Network, is that we have these fixed capacity channels. And what the problem there is that if you want to just randomly send to somebody a huge amount that you would never send to them before, these channels are not really well set up for that, because they have this fixed size and they have these fixed set of relationships, and you can change them around, but that's not really what the design of the channel is for. So that's probably in a sentence, that's the major problem with using Lightning. And there's also some other problems that I think it's interesting to touch on. So one is that Lightning, is a totally new ecosystem, a totally new platform, and we need people to learn how to use it. We need people to develop the protocol out. We need people to develop the software. We need people to build these nodes, these routing nodes, commit their capital. So this is an ecosystem. This is building a marketplace. So without those people, well, the Lightning Network is nothing really. So that's also another major limit of Lightning. And then finally, the big thing that really makes Lightning work or not work is the layer one. So we need to be able to have this assurance that these off-chain transactions could potentially go on-chain. So we can do tons of stuff off-chain, but we always need to kind of make sure that we have this grounding layer one, and we need a decentralized layer one. So we need, I mean, at the moment, like the thing that seems the most promising is that Bitcoin can be that layer one that we need to kind of power this second layer. And even from a currency perspective, we need to make sure that Bitcoin is a currency that people want to spend. So I would say like that's if I were onboarding people to Lightning, one of the biggest obstacles to getting people to like spend on the Lightning Network is just like, why should I even use this weird currency? Like, what's in it for me? Why is it cool? So that's kind of like a limit to Lightning Network's growth. That's kind of out of our control a bit, just as Lightning Protocol does. But it's super important to the growth of the network. Okay, so I just said like that if you want to do like a very rare, very large value, like random type of ascend, that you're going to be constrained, right? Lightning is not going to be well suited for that. So a lot of people like ask the question, well, what is a high value send? Like, is a high value like $5 or $50, $500? So I think that's like the wrong way to ask it, because this is like a marketplace. So it's like an evolving ecosystem. So you can think about it like the internet. So in the internet, you had this kind of interior network of maybe universities all linked up to each other, and the big companies linked up to each other, and they could send to each other really quickly because they had very good bandwidth to each other. But when users would log onto the internet and they wanted to watch a video or something, they would have like the last mile problem, that they would be thinking, oh, well, I can see that this server can serve out high quality video, but then they would use their dial-up modem and they wouldn't be able to watch that high def video. Or it could even be on the opposite side of the problem. So somebody wanted to like upload me this video, and I had great bandwidth, but they don't have great bandwidth. So that's what I mean by high value. I mean that if you have a network where everybody's linked up to each other with like $1,000, with like $1,000, and I'm a rich guy, and so I want to put in like $2 million. Well, I'm still going to be limited by those links. I'm still going to be limited by those the overall like ecosystems money. And like if I try to send to some guy who only has $1,000 like dedicated to him, even though I have plenty of money, I'm not going to be able to reach that guy. So that's kind of like how the blockchain is oriented towards Lightning. So why would you use the blockchain? The blockchain is good if you don't have a ton of repetition. Channels like really benefit from tons of repetition. The blockchain is good if you are using high values, because there's less chance of a liquidity problem, along the path somewhere. The blockchain is pretty simple. Like, if you want to keep your funds like in the safest possible place, I would say, use a super cold wallet. And another thing that I'm going to touch on later is that Lightning really puts a lot more responsibility on you, the user. And the blockchain actually takes some of the responsibility off and kind of shifts it over to like the social network of the blockchain. So another like competitor to Lightning is also custodial settlement networks. So like Liquid, or even like exchanges. Even systems that still use Lightning, like maybe Tippin.me, or like I made one called HLC.me. The custodial actually works really well like on small values, because Lightning has problems settling very tiny values to the blockchain because it's just not worth it to go to the blockchain. Blockchain has certain cost, and if the amount you're trading is below that cost, then there's a problem. And it even does. There's even problems at the very large size. So you can send maybe $10 million on the blockchain, and it's not so bad. But like if you're sending $1 billion on the blockchain, you start to worry about the proof of work. So at that point, you might like you might want to think about custodial services where you have contracts in place, or some other kinds of systems, or you're just going to have to wait for a long time for proof of work to become valid. So Lightning is like not great in those type of situations where you want to do boundless things. And in that case, then if you could find a trusted custodian, and you don't mind taking that trade-off, and you don't want to take the responsibility of your own funds for yourself, then custodial starts to look more attractive than Lightning to, as a solution. Okay, so I kind of covered at like a high level what the limits of like Lightning as a concept are. But if you want to really zoom in on like what are the scalability limits, commonly people talk about like the block size limit, right? Everybody's obsessed with this number that we have a certain amount of transactions that can fit into a block. So I thought it'd be interesting to kind of like look at the transactions and see like visually like how to fit them into the block. So I made a little chart here of a channel, which is just a regular transaction. So you can kind of like look at what bytes are required for a channel. So this is like the absolute minimal channel, and the bytes are mapped into virtual bytes. So you can see that the signature is collapsed because it gets a witness discount. So if you actually counted up all these little boxes, it would be around 112 virtual bytes, just as an estimate. And so that is what is required for a channel, and at the absolute minimum. And that's like our starting point. That's like our atomic unit of how many channels can we fit in the blockchain. And so if we could get channels down to being around 100 bytes, well, there's plenty of space because we have 1 million bytes, every block. But it currently, it doesn't actually work that way. So, there's more complicated things that we would need to do to get to like this ideal atomic unit. So what are some ways that we can kind of reduce the size of channels to become the smallest possible unit? So one way is that we can say, look, if you looked at that transaction, it only had one output. That saves a lot of space. But when you close a channel, you maybe have multiple outputs because at the very least, maybe you're splitting up the money between the two people in the channel. But one thing you can do is you can say, before we close this channel, to reduce the on-chain size, we can rebalance the channel. So we're going to push out one of the output, one of the sides is going to be pushed out somewhere else. And we're going to be able to settle on-chain with only one output. And that'll save us some chain space, some fees. Another way that we can reduce the on-chain space to get to that ideal is that we can say that when we are opening a channel, that we are also at the same time closing a channel, or when we're, the other way around, because that output could be the input to another channel. So then we get kind of like 2 in 1. So that's a trick. Another really powerful trick that we don't support right now, but we can make strides to in the short term, is to turn multiple signatures and I already put that into my illustration. We can collapse multiple signatures into one signature, and that's so powerful that if we there's no like significant limitations to that tool. So we could merge tons of signatures into one signature using signature aggregation, and it would be nice if we had Schnorr and Museg to do that, but we can even do that with ECDSA. Okay, another thing to think about is that right now a lot of times people have this estimate of chain fee space, and they're using the uncooperative close scenario to say, oh well, what happens if one guy goes offline and we have to like broadcast this onto the chain. So in the example that I showed, it didn't have that, it didn't have that complicated script. about that you need when you uncooperatively closed. So we can kind of think of uncooperative closing as a failure condition that we can try to economically incentivize people through time locks, through higher fees, that they should always really try to cooperatively close with other people. And if they can't do that, then they're going to pay a higher fees. And another thing that we already do to save VBytes is that if there's an output that's too small on the transaction, like let's say it's a dusty output, so it's sending like half a penny, and that's possible on Lightning, but you kind of can run into a problem when you try to settle it onto the chain, because the chain will kind of resist economically and also at a like a peer-to-peer level, you spamming the chain with like half a penny outputs. So instead, the software will move those outputs into this like minor fee bucket, where we'll say, well, we're just going to bleed that over into fees, so that if we actually had to close uncooperatively, we're just going to forget about that and just say, let's say that the transaction confirms a bit faster. Okay, another tool that we can use to get towards that ideal is that we can make channels that don't just have 2 people, but they actually have many, many people. And there's drawbacks to that, and it's certainly complicated. That's why that's a limit today. The limit today is that you can have 2 people in a channel. But having more channels, having more members in a channel is actually a super good way to expand the utilization of those VBytes, because you can add tons of members to the channel. So the bounding condition for adding members to a channel is really like, how many outputs can you have? Because you want to be able to say, we could take this channel transaction and settle it to the chain if we wanted to. We're not going to do that, but we could if we wanted to. And so the limit is that everybody's really going to need their own output. They're going to, like, let's say at the end of the day, we close this channel, I want my money. So each output is going to take like around 30 VBytes. But that's something that you're not actually paying until you hit a closed scenario where you actually have a split of the difference, and you couldn't cooperatively fold it up into one output. One important thing to remember when you're talking about these multiple member channels, is that only one person actually needs to fund the channel. So you only actually need one input to go into that transaction. So I can fund a channel, and I can say, let's have 10 people in this channel, but there's only one input that's being fed into this channel, which is my input, and then we're gonna push over more of my input funds into other people's outputs. Those outputs won't be represented on the chain until there's like an uncooperative close where we couldn't rebalance. And this number is actually really high. So we could actually, in theory, get to have thousands of members in the channel, because like I said before, also with the signature aggregation, you can fold in hundreds of signatures into one signature. And the only thing that's necessary when you set up that input is that you are setting up people's public keys, but people's public keys are all hashed together, so there's no space needed. That's a constant size. So this could mean that we could actually have, we could have thousands and thousands of channels per block, and we could have thousands of members potentially. It's probably not realistic, but we certainly have tens or hundreds of members in a channel. And if you do those calculations, that's getting us to like billions of people in even a week. So there's a lot of room to kind of explore the amount of efficiencies that we can pull out of a channel by adding more people to the channels. And that doesn't really require changing the nature of the blockchain. Okay, so going back to more about like the design of the system, I kind of want to talk about what's the scalability design of the Lightning Network, and like how do we achieve scale? So we have like these problems in the system, these responsibilities, and people in the system have to answer these problems. Like whose money is whose? We need to know about that, and we need to know like well, whose money is whose, but also like whose money is how is it controlled? Is it in a channel, or how is it set up? And then who's like validating these things? Who's making sure that all the rules are being followed? And then also, how are we making sure that all the people are getting the right data? So these are like the high level problems for scalability in the blockchain and in the Lightning Network. So the Lightning Network is kind of going on this design path, which is that we are going to share in that responsibility. So we are going to, or we're all going to kind of like individually control as much as we can ourselves. That way, we can add more people, and it's not creating much more burden to the overall system. So one principle that we're going to use in Lightning is we're going to say, you're going to keep the database of your own funds. So nobody else is going to be really responsible for knowing how much money you got. You're going to have to keep track of all the metadata around your transactions, when you sent it, who you sent it to. That's going to be your responsibility instead of a shared responsibility. And when you go to prove it to everybody else, when you do global settlement system, global settlement work, you're going to only present the absolute minimal proof that what you're doing is acceptable to everybody else. So these things are going to make it so that every new user that we're adding to the system, we're not increasing the burden on the overall system, which is not a scalable way to grow. And we're going to make it also that you are only validating, you're only checking the signatures and checking on things of people in the network that you are personally interacting with. So kind of just a small set, a fixed size set of people that you're going to be talking to. It's not like every new person who's coming into the Lightning Network, you have to be checking them out. And that also goes for sharing the data about the network. That we're going to try to make it so that the only data that you need to care about is data that is relevant to you directly, or maybe part of a trade, a fixed set of people. So that way we can say that we can keep adding people to the Lightning Network, and we're not creating a situation where we're increasing the marginal cost to join the network. So this creates actually a problem for the onboarding of people to the network. In the blockchain, you actually have a lot of, let me go back a slide. The blockchain, you actually have a lot of the work is taken care of for you. So you aren't really responsible for the database of your funds. The blockchain keeps that. You can just take your seed and then go download the blockchain, and you can scan for all the blocks to see where your funds are. We're moving more in that direction. There's a lot of proposals that you would keep more responsibility so that we could scale layer 1, but that's not currently how it works. You need to, currently you can just forget everything except for your seed, and that's fine. And on the blockchain, the reason it's difficult to scale is that we have, the more people that we add to the system, the more people you have to validate. And that means that we add 1,000 people, and now everybody in the network has to check out these 1,000 people. That doesn't scale very well. And then also in terms of sharing data with people, the more people who join, the more data there is. So it just creates this mountain of costs that's growing. So it's nice though, that other people are taking care of stuff for you on the blockchain. And it's kind of not nice in Lightning, where you have to really be responsible for your own stuff. So what happens if you lose your database? Well, because we sacrificed the communal responsibility of the database, now that's your job. You have to, you're out of luck if you lose that database. So one thing we can do to kind of address that problem is that we can say, let's have kind of proxy responsibility. So it's not just going to be all on you. There's going to be some shared responsibility, but you're kind of in control of how much you want to share it out. So we have this thing called the Data Loss Protection Protocol, which Lightning, which LND will require now, is that your peers are going to have to be keeping a minimal set of data for you, so that if you want to close a channel and you've lost some data, they need to kind of be around be keeping the appropriate data to help you close it. We're gonna, we just added in 0.6 this ability to create this static channel backup system. So it's just a very simple set of data that you can copy around, and that you can copy to, some kind of like peer-to-peer service, or you could just copy it to Google Drive or wherever you want, because it's an encrypted file and it's pretty small. We're working on the Watchtowers project, which is that you can make it so that if you don't really want to be monitoring all the time, or maybe in full responsibility for monitoring your channel, so you can outsource that to a Watchtower. So in the blockchain equivalent, if somebody tried to do a double spend or something, the overall like social network would like crush that. They'd be like, oh, you can't do that. That doesn't make sense. Or if they try to do something invalid. So if you relate that back to Lightning, you could just say, okay, I'm going to choose these people. They're going to be kind of like my watchers. I could do it all myself if I wanted to, but that would require me to like be online. And then also, since the blockchain is like a shared ledger, it's sharing all this data, it's like keeping it around for you. You have this problem where you can't really receive if you're not around to receive it. And we can kind of proxy responsibility in that way too, where we can say that another node can kind of act as a mailbox for you. So he can just delay the delivery of that final HTLC, and then he can maybe send you an email, or you can come back online once a day or something like that to check on if there's anything around in your mailbox, and then you can take that final HTLC step. And the key thing to think about in all of these different ways to proxy is that, yes, you do kind of like rely on somebody else, but you also are relying on them in a way where they can't just like take your money. So we can kind of create moderated solutions for delegating responsibility. Okay, so another like super popular limitation that's talked about for Lightning is how are we going to do routing? And it is difficult. Like routing is a difficult problem on the Lightning Network. So the theory of a Lightning Network is basically you have like the 6 degrees of separation. So you have all these people in the network, maybe billions of people in the network. And it seems like a very difficult task. How do I know to get from 1 in a billion to the other in a billion? But once you start thinking that people have relationships where I know somebody who knows somebody who knows somebody, actually it's not that difficult to be able to theoretically reach them. So the limitations on making that actually work, though, is that in all of these billions of people, you actually don't know who is online at the time. So how do you know who can even help you get to that person? So it's not enough to just know that they have some connection. You also need to know that they are, can respond to routing requests. And you also don't know like how much money people have in their channels. So maybe you need to figure out like some path which is balanced, where they have the rights, the balances on the channels are set up in the right way that you can actually send to whoever you're wanting to send to. And even the idea that you would be like that a mobile phone would even know about billions of people in the world is a challenging idea, because that's a lot of data to keep up to date. So it's probably infeasible that we would have a complete knowledge of the graph. We're going to need to have something where you're going to have to not know some subset of the graph. And there's another problem with routing, that and this is a major problem, that what happens if one of these nodes doesn't forward along your HTLC? So they just sit on it, or they cancel back to the chain. All of the smart contracts that make the power of the Lightning Network are based on these like block times, and the block times can take a long time. It can be theoretically days. You can like LND will now allow you to set what you want as your acceptable time, but it also has to be acceptable to the routing nodes who are forwarding for you. And another tricky thing is, because the Lightning Network is this onion routed network, you don't know exactly who held it up. You kind of send it off to this route, and somewhere along the line, somebody's holding it up, somebody's delaying things, but you don't know exactly for how long it will be sitting around, or who's doing it. And this is you're not going to lose money, but this is time And this is locked up capital, which is annoying certainly, and you just want to make your payment, and so that's also a routing problem. So one solution that is in the works to kind of solve these problems, is to separate the nodes into kind of like different responsibility roles. So the thing about the network is that you can think about it as that everybody can potentially be equals in terms of they can serve all the same roles if they wanted to, but some nodes are going to want to serve different roles than other nodes. So easy way to think about that is like a mobile node. He probably doesn't want to keep his phone online, connected to the internet, have millions of peers, be doing all of this work. He wants to just be somebody who's a spending node. He could, if he wanted to, be a routing node, but he doesn't. That's not what he's looking for. And then we'll see specialization in terms of routing nodes. So we'll have a certain set of nodes who do want to be forwarding payments and earning those fees, and so that we'll have a stratification of the network into these different types of nodes. And if we can set up this network where we can identify who are people who want to be routing, and we can say these routing nodes, we want to identify them as behaving in a certain way. So a routing node is somebody that we're choosing, like with our market buy of routing. We're saying, I'm going to choose you to send my traffic through you because it looks like you're online a lot. I don't have a lot of failures through you. Things happen quickly. And if we can make this kind of a network where we have people at the edges, like these, mobile wallets or people who are not interested in routing particularly, or maybe not good at it, they're all at the edges. And then in the center, we have kind of these people who are like wanting to run these nodes that are great at routing and always online and doing, an amazing job. Then we have a much better picture of how to map from A to B on the network. And it kind of models in the internet how you can run a web server on your laptop, but you don't have to. You can run it on a server somewhere, and still it's kind of up to you how to set it up. But like you might want to choose a server if you want to be routing on the internet. So this makes it so that this also deals with the problem that we have, which is capital. Which is capital like liquidity problems. So if you can think that routing nodes are like the broadband equivalent, so they have very high capital links to all of the other routing nodes, then you no longer have to think about the liquidity problem to get to your destination so much, because you can rely on the routing nodes to be very well connected to each other. And then your only problem is, can you get to the routing node? And then there's an equal problem on the other side, which is, can the receiver get from the routing node what you want to send? And that makes the problem a lot simpler, because instead of having to worry about 6 hops all having proper liquidity, you only have to worry about the first hop, which is you, and then the final hop, which is your receiver. And in order to get to that place, we need to build a market. So we need to make it so that people are like rewarding these routing nodes for doing their job, and that routing nodes are easy to run, they're cheap to run, so that they can charge limited fees. So that's kind of like a market process and also a software process. Another way that we can deal with this, so once we have this network of like these great routing nodes, it also solves a problem, which is the graph computation. So I'm 1 in a billion people, so I need to get from my node through the network of a billion people to somebody else. So how am I going to do that? I might not even have the whole graph. So this actually was like thought of ahead of time. And so in the specification for the payment request, you can actually include these like reference point nodes for kind of how do you get from a reference point node to my own node. And so you can think of all of these great routing nodes as reference points. So when I send a payment, I can see reference point nodes. Because there's a limited number of them, and they're all kind of pretty well linked together. And I don't know exactly how to get to you, but in your payment request, when you sent it to me, you included like the path, the final part of the path that gets to you. So that makes routing way easier. We can even also just outsource routing, period. So even the computation itself. So people are talking about this recently on the mailing list about how to do that in a private way. But if you didn't want to do it in a private way, you can just pay to somebody who you're able to pay to, and they can have the harder job of like synchronizing the billion people in the network, and they can do all that work of figuring out the cheapest mode of figuring out how to get to them. And so you can outsource that without trusting them because you can lock it to the same payment hash. And then I think also there's a trade-off with outsourcing. There's a trade-off with the whole network, which is that you probably won't get the perfect route. Like there probably will be something that's a little bit lower fee. It's a little bit more private. So graph algorithms currently, like LND will just focus pretty much on getting you the lowest fee, and then it will just try, okay, what's the next lowest fee? The next lowest fee. But instead, in the future, we can say instead of we just recognize we have that limit that there's no way to get a perfect route, so we're just going to get an acceptable route, and that'll be good enough. Okay, so another super big limit on the Lightning Network is that I talked about before, is that we have this like capital limitation that you have these small channels, these small outputs. You send around 100 satoshis, but it can't really settle to the chain. Then if you have a bit more money, like $5 or whatever is related to the current fees, the current usage of the chain, you can settle that to the chain. And then at large values, you start to run into like this liquidity problem. So that's kind of like the fundamental structure of Lightning's limitation. So one solution that doesn't totally solve it, but really helps a lot, is this idea that you can take multiple paths to your goal. And there's lots of different ways that we can actually implement that. So one way that we can actually do right away, and that I know has been tested on the real network, isn't too difficult, is this idea of base amp. And so what that is you kind of negotiate that I want to get like $100, and I'm going to say I'm going to wait for HTLCs that equal $100. So you're going to be able to send HTLCs through a bunch of different paths that add up to $100, and then the way that I'm just going to like wait before accepting them all, and I'm going to have them arrive at my node, but I'm not going to like reveal the pre-image. And then once I get to $100, I'm going to reveal the pre-image and take all of those. And that's a secure way to actually do AMP. It's very low tech, and that's something that you can try out right now. Although the clients don't have great support for it. Another way to deal with sending more money, like avoiding like this maximum limitation of a channel, is that we can say if you have multiple channels in the same direction, you can do that same trick where you just wait for multiple HTLCs, but you just do it between two different peers. And that's something that you don't even need the sender and the receiver to know about. That can just be on the path. And then, of course, in the future, we can go to this idea where we take the pre-image and we shard it into a bunch of different secrets, and then the receiver cannot take it, even though, like in base AMP, they are like economically incentivized to wait around. In using Schnorr, using like more advanced constructions, we can say that even if they wanted to take it, they wouldn't be able to take it. And another thing is that we can do in the Lightning Network is just accept that like it has its limitations, and that we can come up with all these tricks about how to deal with situations that go to the edge cases. So we, at the small size, we can say, let's just bump these tiny outputs into fees. And we could do, crazy stuff like we could do probabilistic payments. So we can say, let's just bump this into like a 1% chance that you get $100 or something like that. We can also, use a chain, or we can use other chains. Like we can use, liquid side chain. So that can really come in handy when like we're trying to, like, let's say we're closing the channel and we need to like move the flow around so that we can absolutely minimize the size of the channel on the chain. So we can move all over those other outputs into using submarine swaps, using these other chains, using all sorts of different methods. We can also fall back to the chain, we can say, let's integrate chain sends and lightning sends into the same wallets. So like if the amount that's being sent is just too much, let's just accept a fee. We'll go onto the chain, and these will work together. And something also that people are experimenting with now is this idea of turbo modes, where in certain situations it can make sense to do zero confirmation channels. So that means you can kind of like get the best of both worlds, where you can still stay in a lightning system, but you can use the chain's ability to move capital around in a random high value way. Another way that I think would be cool that, I don't know if anybody's working on this, is that at the small scale, we could use kind of like blind signatures to deal with like these little commitments that we have between nodes. So we can use like eCash so that you can kind of like privately trade around these like tiny commitments that don't really make sense on the chain. And then finally, another thing we can do, like to make to lift the capital limits, is that we can like grow the sophistication of this capital market. That's another thing that people are working on. Like Bitrefill is working on these turbo modes, but they're also working on the Thor project that would allow you to sell out, to buy inbound liquidity. And that's something that I've been working on at Lightning Labs, which is the Lightning Loop project. And the more tools that we have, the more sophisticated buyers and sellers we have in this market, the more we can grow the ability for you to escape the limitations of that capital. Okay, I put a lot of stuff into this presentation. So one thing I want to talk about is that the 1.0 protocol actually has these annoying limitations, and I just want to kind of highlight them. And also, it's important to think about Lightning as it's not like a protocol that's fixed in stone for all time. It's something that we can adapt and grow, and that's a great thing. So the number one problem in 1.0 that I think needs to be fixed is that when you have a force close of a channel, the force close output that goes back to you is using a randomized key. So if you just have your seed, you won't be able to go to the chain and scan all the blocks and find that funds, because it's using a randomized key and you don't know that random number. So that's kind of like a problem in 1.0, and that increases the amount that you have to rely on keeping the backups for yourself. Of like, you have to keep every time you have to keep that random number around. There's other problems, which is that when you have the transaction closed to the blockchain, it can be locked to like this CSV output, which means that it can't be respent until a certain amount of time has passed. So a certain number of blocks have to be passed before it can be respent, and that creates a problem where you can't bump the fee using child pays for parent on the parent, because you can't spend it until you wait for a bunch of blocks. And child pays for parent requires you to get the parent and the child into the same block to bundle up that benefit to the miner. Another problem that we've had and we knew about is that the channel capacity amounts are fixed, and we also have a limit on the channel capacity, which is pretty low, like 0.16. So that creates lots of problems in terms of like, do we want to build this out to exchanges? It's difficult to do that. And another thing that just like housekeeping, is that if you have funding transactions that don't have a good fee, because there's some kind of a fee spike, it's difficult to negotiate with your peer about how to like bump up that fee. And then also, Lightning has a limitation right now just because the protocol doesn't support it, which is you can't push a payment to somebody. They don't know how to receive that. So in 1.1, we'll add all sorts of new features to solve all these problems, hopefully, if it all gets done, which is that we're going to make the remote addresses static, so that if there is a force close, you'll be able to scan the chain. So you won't have to like keep around that random number anymore. On the CSV constrained transactions, we're going to add these other hooks. Okay, I'm out of time, so I'm going to stop the share and do quick questions. Okay.
Hey everyone, so yeah. If you guys have any questions for Alex, please type your questions in the chat box, and then I'll try to get to them. We actually already have one person who has a question and says, do AMPs not have the same problem as the current system where one node may not forward the HTLC and that will lock up liquidity? How would that be dealt with?
Yeah, for sure. So number one, I think you have to think about the routing node network. So you're not sending through like totally random nodes. You're sending through a network of nodes who are specialized. So the fact that they're specialized gives them this big incentive to not do weird stuff. But you still have the problem, which is like you don't really know exactly which node does something weird. So there's other ways to deal with that. Once we have these push payments, or once we have more interactivity with the receiver, we can actually kind of like pre-figure out the route by like trying something out first and seeing if that works. And we're not using real money in that situation. We're using a fake hash, which they don't know. And so we can say, oh, this went through. So probably we can just send it through again. So we can make that more and more of an edge case scenario.
Okay, cool. So the next question is how to solve the issues of network-wide channel balancing. Seems a little broad.
Yeah, I mean, I do think that we need like a more sophistication in the like the idea of capital as a good. So liquidity is like a product. And so, I see people like mention in chat, which are like, oh, can you throw some inbound liquidity my way? I think the way that will mature is more like, well, if you want inbound liquidity, just go to the inbound liquidity market and say, look for whatever type of inbound liquidity you want. And then they'll be that, once we grow the sophistication there, we can say there's easier ways to handle your specific liquidity problem.
Cool. All right. Another person asks, a little unrelated, but was wondering, is it possible to change the minimum HTLC that can be forwarded on a channel after it has been opened?
Yeah, I think that's adjustable. You can just say, it's like part of the channel policy. And of course, it's technically possible. You just see an HTLC come and you're like, oh, that's too small. And you say, no, I reject it.
Got it. Another question is, I think he's talking about Wumbo here. Are we going to increase the capacity of channel in 1.1?
Yeah, so it will be effectively unbounded. The channel capacity will be unlimited. But you'll still have that problem, which is that, number one, we probably will want to have some like default safety limits just to say, like, let's negotiate like something reasonable. And number two is even if like one node in the path has a huge capacity, it doesn't mean that all the nodes along the path have that capacity. So it's probably better if we grow it slowly and together as an ecosystem.
Okay. Another question is, I want to move my LND node to .onion network to hide my AP, but I also need to have access to LND REST API for his e-commerce store. So how would you suggest that he solves this problem? Use VPN instead of Tor?
No, I mean, you can, like Tor is just applicable to the Lightning node itself. So I do this with my own node on yelp.org, which is behind Tor. And I suggest people set up their nodes behind Tor. It's pretty cool. And then it still leaves the normal networking open, so you can know about the IP address and use it that way.
Okay, few more questions. What first end use cases or services will 1.1 open up in your opinion?
I think that the push. I don't know exactly what's going to be 1.1 because it's still being worked out. But like the push payments is the thing that I'm most excited about because it allows for like interactivity, back and forth interactivity that's totally on the network. So you can have APIs that only exist in the Lightning Network that are nowhere else. You don't need to have, an HTTP REST API or something. You have the Lightning API. That seems like the coolest thing to me.
All right. Last question is, what resources do you recommend for a dev who's trying to better understand the Lightning Network?
I definitely like the Bolt RFCs. That's where I started. I just went over all the different RFCs. I mean, they're changing around, but like you can look at the chain transactions and stuff. And then Lightning Labs has like a API development system, and I have like my own library that I built, like LN Service, that tries to make things like easy to get up and running. And that's what I use when I built YAWS and built like HLC.me.
Perfect, Alex. Thank you so much for your time. I was super excited to hear your talk, and the fact that we can onboard billions within a week, that's pretty crazy because I know that was one of the major criticisms, I guess, to blockchain's block space and all that good stuff. So thank you for your time. You guys can reach out to Alex on Twitter at alexbosworth.com with your further questions. He's very responsive there. Okay, I'll see you guys next time, and jump onto the next Connor session once we start. We'll start it very, very soon. Thanks, guys.
Thanks. Bye-bye.